Okay, kiddos, so this is going to be your lesson 3-2 video. Today we're going to start messing with linear systems with 3 variables now. Okay, and here is our essential questions. How do we use substitution and elimination to solve systems of linear equations with 3 variables this time? And just like last time, how can we formulate systems of linear equations that model real-world situations? So right here we have a real-world situation. A snack company plans to sell a mixture of peanut butter, grape, jelly, and granola as a sandwich spread. The table gives information, blah, blah, blah. Okay, so an 18-ounce jar of the sandwich spread will have a total of 2,273 calories and 150 grams of fat. Write and solve a system to find the number of ounces of peanut butter, grape, jelly, and granola in each jar. So what we're going to do here is just read from this and set it up as a system. And you're going to see this is a little bit more complicated of a system than the ones that we've been seeing before, right? So basically, what we're saying is the amount of peanut butter plus the amount of jelly plus the amount of granola, it should all add up to an 18-ounce jar. Let me switch to a neutral color here. It should all add to an 18-ounce jar. Okay? And we're also saying the amount of calories should add up to 2,273. So if we're looking at calories per ounce, we would have 168p plus 71j plus 132g for granola, right? It should add up to our 2,273. Okay? And right here, grams of fat per ounce. So now pretty much the same thing as our last equation that we just plugged in, right? So we're going to have 14 peanut butter, right? So 14 ounces per, 14 grams per ounce of peanut butter of fat, right? And then for grape jelly, we've got 0, so we would just say plus 0 jelly, right? Or 0j, and then plus 12g, right, is equal to, it should add up to the 150. Okay, and I'm not going to solve this system. I'm going to leave that for you to do as extra credit. If you can solve this system and show the work using one of the 2 methods that we're going to learn today, I will award you extra credit for that. But to keep this video short and sweet, I am going to avoid that. And also, same for the lesson. So anyway, so we've got a linear system here, and just like how we have the simpler systems, we can use substitution. But you're going to see substitution gets gnarly whenever you get into, so let me back up. So looking at this, right, we've got a system of equations here. There's 3 rows and 4 columns, so we call this a 3x4 linear system. Okay, a 3x4 linear system, or a linear system with 3 variables, whatever you want to call it. But this is what I'm calling it, is a 3x4. So 3x4s are gnarly. You can see I got a little dyslexic up here in the title, but that should read 3x4. I'll have that fixed by tomorrow. Anyway, so the way we can use substitution is pretty much the same way we used substitution in the past. It's just a little more complicated. Not even going to lie to you. Okay, so the first thing I want to do is I want to isolate one of these variables, either x, y, or z. And again, you see when we arrange these systems, we write them out with the variables in alphabetical order, and you have the constant here on the right. Okay? So I'm going to go ahead and, because if you look, z is going to be the easiest one to get by itself right off the bat. And I'm going to go ahead and get z by itself. Okay, so z, if I do minus 2x minus 7y, so z is going to equal negative 2x minus 7y minus 53. Okay, and we're going to use this little guy right here for z. We're going to use him to substitute into this other equation right here. So this second equation, we're going to substitute what we got for z into here. So we're going to say negative 2x plus 3y plus z, right? This is all z now, okay? So plus z, so negative 2x minus 7y minus 53, is equal to negative 13. So one more time, I've got negative 2x plus 3y plus z. I have a different z. I've substituted. Okay? So all I'm going to do is quote-unquote distribute this plus sign, which really does nothing. It doesn't change anything. So this is still going to be minus 2x minus 7y minus 53 equals negative 13. But what it does let me do is get rid of those parentheses. So 3y and negative 2x. Now this is important. The most important thing in solving a system of equations or doing anything gnarly like this in later algebra to come, especially in college algebra, is staying organized with your terms, right? So I'm going to combine like terms, and I'm going to mark off every time I have accounted for one of those terms. There's a whole bunch of terms, right? So negative 2x and negative 2x, those are like terms. That's going to give me a total of negative 4x, right? And I mark them off to make sure that I, am keeping track of them. 3y and negative 7y, that's going to combine to give me negative 4y. And we can't do anything with this negative 53 except add it, right, to both sides. Okay, so equals, so negative 13 plus 53, that's going to give me positive 40. Next thing I can do, these two terms here, negative 4x and negative 4y, they both have a greatest common factor of negative 4 that I can quote-unquote factor out. So I'm going to go ahead and do that. And that leaves me with x plus y equals 40. Now I can divide both sides by negative 4. And that's going to leave me with x plus y equals negative 10. Right? So now I have a choice. Do I want to go ahead and solve for x or y? I'm going to go ahead and solve for x just because it just seems easier to just slide that guy over. So I'm going to subtract y from both sides, and now I'm going to have x is equal to negative y minus 10. Okay, and I'm going to write this over here to the side because I'm going to start running out of room. And yes, it's a lot of writing to solve a 3x4 linear system. It's a lot of writing. Well, at least when you're using substitution, it's a lot of writing. So I'm going to erase, give myself some room, and I'm going to keep that little equation that I've got there for my x over there to the side. And what I'm going to want to do next, okay, is I'm going to want to plug in both x and z into this x and z. All right? So 6x, x is negative y minus 10. Okay, and what I'm basically doing is I'm basically starting to limit down. So when I plug in, I'm going to have everything in terms of y, which is incredibly good for me. You'll see here in a second. So 6x plus 3y, and I haven't substituted for y yet. 3y plus z. Well, z is this guy right here. So I'm just going to throw that in there. So plus z, negative 2x minus 7y minus 53 is equal to negative 45. Once I've worked some of this stuff out, then I'm going to take this x and plug it into here as well. Okay, but I'm not going to do that yet because that's going to get too gnarly. Okay, so what I'm going to do first, now that everything's substituted for now, I'm going to go ahead and distribute the 6. I get negative 6y minus 60. Plus 3y. I'm going to go ahead and distribute the plus. So minus 2x minus 7y minus 53 and equals negative 45. Again, I'm staying perfectly organized as I stinking can. Okay? So I'm going to start combining like terms. So I'm going to start with the y's. So negative 6y and positive 3y, that gives me negative 3y. Negative 3y plus another 7y, negative 7y. That's going to give me negative 10y total. Okay? Negative 60 and negative 53. That's going to give me negative 100 and brain fart, 113. And then I've still got my negative 2x, just going to bring that guy down because I have nothing to combine it with, equals negative 45. Now, I know what x is. I can go ahead and substitute now. Okay, now that it's a little bit less ugly looking, I'm going to substitute this guy in for x over here. Okay, so I've got negative 10y minus 113 minus 2 times negative y minus 10 equals negative 45. All right, now now I'm just down to just one variable. I'm all in terms of y, so now I'm going to be able to solve for what y actually is. Okay, so that's the whole point in doing this. We're eventually getting to where everything's written out in terms of one variable. So now I'm going to distribute my negative 2. So negative 2 times negative y, that's going to give me plus 2y and plus 20 when I multiply by the negative 10 equals negative 45. Now I'm just going to bring everything down. All right, and then again, I'm combining like terms, negative 10y, positive 2y, that gives me negative 8y, and negative 113 plus 20, that's going to give me negative 93, is equal to negative 45. Now I'm going to add 93 to both sides. Okay, 93 minus 45. That's going to take me a minute. So I'm going to have negative 8y is equal to negative 45. Well, I have a calculator here. So yeah, cut me some slack, guys. It's 8:40 at night, and I am super tired. So I got negative 45 plus 93, and I'm going to get 48. Positive 48. And I'm going to divide by negative 8 on both sides to get y by itself, and I get y equals negative 6. And I am well on my way. To having this guy figured out. So the hard part is out of the way. This was the hard part. When you do all that substitution, it gives you just a whole mess of numbers everywhere. But again, the important thing is stay organized and you'll be good. Okay, so what I'm going to do now, I'm just going to plug this y into this y right here. And then that's going to give me my x. So now I've got x equals negative y, right, minus 10. That's a double negative, so that's just 6 minus 10. And x is therefore equal to negative 4. So x equals negative 4. Easy peasy, right? Now I can just take my x. And my y and plug them both into here. So substitution is gnarly. Substitution is gnarly once you get past the little 2x3 matrices or systems. Okay, so negative 2x, right, minus 7y minus 53 equals our z. Okay, that's going to give me positive 8. That's going to give me positive 42, and then minus 53, and that's going to give me my z. 8 plus 42 is 50. 50 minus 3, here, I'll write it out. 50 minus 53 is going to be negative 3. And there is my solutions. So my set of solutions to this, my only solution to this system would just be written out as the ordered pair. So this is three-dimensional because I have 3 variables. If you remember from geometry, we talked about it briefly. You've got x, y, and z. This is a 3-dimensional problem. So when you do an ordered pair, right, you're going to do x, comma, y, comma, z now. So x is -4, y is -6, and z is -3. And this is how I would write out my solution to this system. Okay? So now we're going to do a much, I shouldn't say much easier, but it's definitely going to be less brutal than doing regular substitution. So we're going to do elimination. And again, elimination hasn't changed much in this type of system as it has from the last type of system, the smaller baby systems. So it's the same idea here. Okay, so looking at this, at these first two equations in this system, we can already see where we're going to have an elimination there of the x variable. Okay, so what we can do is go ahead and just add them like we would doing our regular elimination, right? So -2x plus y plus 2z equals 6, right? We can go ahead and add them. So that's going to cancel. So I've eliminated the 2x. So that leaves me with just, so I'm just going to add. So that leaves me with just 2y, and then so -1z plus 2z. That's going to give me just positive 1z, or just plus z equals 10. Okay. And then what I'm going to want to do, I want to get another equation with just two variables. Okay, I want to get another equation with just two variables. So I'm going to take this guy here and this guy here. Okay, so I want another equation that looks like this one, that looks like this guy right here. I want to eliminate another one, right? I want to eliminate x from somewhere else to where I get y, z, and my constant. Okay? So what I'm going to do is use this first and last equation, and I'm going to go ahead and write them out and see if there's a way I can eliminate an x, and I can already see it. 2y plus z equals 11. So if I just multiply this bottom guy right here by -2, I'm going to be able to eliminate the x's, and I'm going to be left with y and z, just like I am over here on the right with my other two variables, right? So I'm going to have -2x when I distribute the -2. So -2x minus 4y minus 2z equals -22, right? So I'm going to pretend like that's gone. And then when I combine them, 2x minus 2x, that's just going to give me an elimination. Plus y minus 4y, that's going to give me -3y. Negative z minus 2z, that's going to give me -3z, is equal to -18. Right? And what I can go ahead and do to save myself some trouble, just like I did in the earlier example, is go ahead and factor out a common factor right here. So I'm going to go ahead and factor out a -3, and that's going to leave me with y plus z equals -18. Go ahead and divide by -3, divide by -3. That's going to leave me with y plus z equals +6. And that's going to be much easier to work with over here. So y plus z equals 6. So now that I have that, right, I want to go ahead and eliminate something from here. Well, the simplest thing to do, I think, would be to eliminate z by just multiplying this bottom equation, or the top one, it doesn't really matter, by -1. That's going to give me -y, -z, and -6. Just going to flip all the signs when I multiply by -1. Pretend like that guy's gone. Then I'm going to combine here and eliminate my z, right? And that leaves me with y is equal to 10 minus 6, which is 4. So I already have my first answer. Okay, so now that I know what y is, I can go ahead and plug into here now. So y plus z equals 6. Subtract 4 from both sides, and z is simply 2. So now I have two of my answers. now that I have these two, I can go ahead and just pick one of these that I want to use, and just plug in for y and z, and then I can solve and get my x, and then I have my complete solution. So I'm going to have 2x plus y, which is 4, minus z, which is 2, equals 4. And 4 minus 2, that's going to give me 2 equals 4. 2x, bring everything down. Subtract 2 from both sides. I'm going to be left with 2x equals 2, and therefore x is 1. So my solution is x, y, z. And that's about all there is to it. Elimination is much simpler on these. Substitution obviously gets really, really ugly. So now the rest of the class period, you're going to just do the practice. Same thing in the lesson. The lesson in class should go about this quickly. And again, don't forget, you've got this extra credit. Where'd it go? You've got this extra credit opportunity here. So now that you've learned a couple methods how to deal with these, have at it. And if there's anything you need as far as the practice or anything else, shoot me an email. You guys know. All right. That's all I got for you on this video. Goodbye.